Hello students, welcome back. So now I'll be talking about loss function and cost function. A loss function, it is the error for one data point. That's it, just for one. Cost function on the other hand, it is the average error for every single data point, for all data points. Now let's understand this through a simple example. Suppose we are working with linear regression model. So the loss in linear regression model would be something like this. Your y actual minus the y predicted, and then you square the value. This is what your loss is. This is what you do for each data point. Your cost, on the other hand, would be you're taking the loss for every single data point and you add them all together and then you divide by the total number of sample points. So suppose this is my data right here. This is my x right here. So in this case, x equal to 143, and this is the y actual. These are my actual values of y. So in this case, 243. And let's say your linear regression, it makes a prediction. These are your predicted value. So the loss for the first data point, that would be this right here, would be 2 minus 1.5 square. This one right here, according to this formula right here. So the answer will come out to be 0.25. So this is my loss for one data point. Now let's do the same thing for the second data point. So my actual value is 4. My predicted value, let's say, is 3.4. So my loss will come out to be 4 minus 3.4 squared, and the answer is 0.36. And likewise, you can do that for the third one. So these are my three loss for the three data points. My cost in this case would be you're adding all the losses together like this formula right here, and then you divide by the total number of data points, in this case by 3, and the answer comes out to be 0.47. So this is my cost. And now let's take a look at some of the examples of loss functions. One of them is a mean squared error, MSE. This one is used in linear regression. This is how your loss function looks like. In this case, your loss is going to be your actual value of y minus the predicted value of y, and then you square that. So your y is actual value, prediction is your y hat. This one is used for house price prediction, for salary prediction. Then you have mean absolute error, MAE. This one is also used for linear regression. Here your loss is actual value of y minus the predicted value of y, and you take the absolute value. So let's say your actual value is 20 and your predicted value is let's say 21. So in this case, your 20 minus 21 is minus 1, and then you take the absolute value and the answer will come out to be plus 1. In this particular instance, this will be 20 minus 21, that would be minus 1, and then you square that and the answer would be plus 1. And then you have binary cross entropy. This one is used in classification, and the loss function is given by this expression right here. In this case, your y is going to be either 0 or 1. So y is your actual value, and your y hat in this case is your prediction. These are your prediction right here, this one and this one. And then you have hinge loss. This is also used in classification, and this one is used by SVM model. Again, here your y is going to be 0 or 1, and the loss function is given by maximum of 0 comma 1 minus y dot y hat. This is your actual value and this is your predicted value. And then you have categorical cross entropy loss. This one is used for multi-class classification. For example, when you have more than two classes. So for example, that would be digit recognition. You have 0, 1, 2, 3, all the way up to 9 digits. So you have 10 classes over here. Animal classification. Maybe you have an image or maybe you have some characteristics and you want to determine whether it's a dog, cat, or snake. So in this case, you have 3 classes. Here, my loss function would be given by this expression right here. My C in this case, that would be this right here. This means number of classes. Your yi, this would be your actual label. And by the way, your actual label would be one heart encoded. And your yi bar, this is yi hat, that is your predicted probability. Another interesting one is the Huber loss. This one is used for regression. Now, this one actually combines the advantage of your MSE and MAE, mean squared error and mean absolute error. And this is the function for your loss. This is the loss function. In this case, your Y, that would be this right here, these values, these are your actual value. Your Y hat, that is your predicted value, these ones right here. And your del right here, this is your threshold. Then another one is KL divergence loss. This one measures the difference between the probability distribution. This one is used in VAEs, variational autoencoders, also in generative AI, in knowledge distillation. And this is the formula for your divergence loss. In this case, your P, that would be a true distribution, and your Q, that would be the predicted distribution. And then there is also a focal loss. This one is used for imbalanced classification problem. For example, in fraud detection, cancer detection, you don't have many fraud, you don't have a lot of cancer. That's why these are imbalanced. In this case, my focal loss would be given by this expression right here. Here, my PT, that would be this right here. These terms right here. These are your predicted probability of the correct class. That's the one, correct class. Your alpha, that would be your class weight. That would be this one, and your this one right here. This is called focusing parameter. This is called gamma, the focusing parameter. And then there is dice loss, and this one is used in image segmentation. This one measures the overlap between the prediction and the ground truth. The formula for this one is given by this expression. First, you calculate your dice coefficient, then you calculate your loss. In this case, my A and B, A refers to the predicted pixels and B refers to your actual pixels.